Okay, so we have 9.4 to do, which I was thinking we were stopping at 9.3, but no, we have one more. So this is good because I was kind of wondering where this topic was going to come up, and it wasn't in 9.2 and 9.3. So, okay, so it's all in 9.4. But let's look at a situation. Say you have plastic cups that you're stacking. Like you have one cup, and then you have 2 cups on the next row, and 3 cups on the next row. So maybe some of you have done that with plastic cups or something else, and you're stacking it into like a little pyramid. And that actually is another little topic that you could talk about, but just using this as an example. So the question is like, how many cups do you need to make that pyramid, right? So we're looking at what's called a series. So you have the first row, you have 1 cup. The second row, you have the second row, I want to write it like a sequence. So you have 1 cup, then you have 2 cups, then you have 3 cups, then you have 4 cups. That is a sequence. The sequence is 1, 2, 3, 4, and so on. A series is when you add up those cups. So a series would be 1 plus 2 plus 3 plus 4 plus, and then it keeps going, right? So it's when you add up the terms in a sequence. So a series, here's the definition from the book. It's a good, nice little clean definition. It's the sum, okay, I just misspelled sum. So sum of terms in a sequence. Now it doesn't say what type of sequence necessarily. Could be any type of sequence. Could be arithmetic or geometric, or it could be something else. But it's the sum of terms in a sequence. Okay. So here's a sequence here. I'm sorry, a series, because you're adding those terms up, right? So there's a sequence, there's a pattern, 3, 7, 11, 15, 19. This looks like an arithmetic sequence. Arithmetic series. I'm going to keep messing that up. Arithmetic. I might have misspelled that too. An arithmetic sequence. Series. Okay. So let's say you want to do a partial sum. So here we have, it's 3, 7, 11, 15, 19. You can see the common difference is 4. Okay, so the difference is 4. But let's just say we want to add the first 3 terms. Then the notation we use is S sub 3. So I guess I should mention S sub n, that's the sum of n terms. The first n terms, okay? So you start with the first term. You always start with the first term. And this is a finite number of terms that you're adding, okay? So S sub 3 for us would be those first 3 terms. So that would be equal to 3 plus 7 plus 11. So you could add those up, and the sum of the first 3 terms here, it would be 21. Okay? So we can do a partial sum from a series by having a finite number of terms, and you're adding up those first terms. So if S, if it had been S sub 4, then we would have taken the first 3 terms, 3 plus 7 plus 11 plus 15. So that'd be 36, right? Okay, so that's what we're talking about here. Now we have a special notation for sums, and it's called summation notation. And we use the Greek letter sigma. It's a capital sigma. They have uppercase and lowercase letters. And so there's the sigma. That's as good as I draw them. Here's one that's typed, so you can see that a little better. And the variable here is k. K is the index. So it's the variable in your summation notation, okay? Our lower limit here would be 1. So our lower limit is 1. Okay, so that's going to be at the bottom number. It tells you where to start. Now, when we had partial sums, we were always starting with the first term. But with summation notation, you don't necessarily have to start with the first term. You could go from any term to any term. Okay. Also, I want to mention our summation notation here is using k. But another common index is n. Sometimes they'll use n. They can use other variables. Sometimes the lower limit is 1, but sometimes it's 0 or 5, or it could be any integer, but it's indicating the term that you're on. The upper limit is up here at the top, so in this case our upper limit is 5, and it could be a different number. You know, you could be adding the first 3 terms or the first 10 terms or something like that. The explicit formula, now that's kind of the important part. That is, in our case, 2k. So it's going to be based on the variable that you're given, and that's how you find the terms. So it's how you find the terms. Okay, so our sigma notation here says we're going to add, it's a summation thing. I don't always put the little ends on there, but we're going from k equals 1 to 5. And the generator, or the explicit formula, is 2k. So to find the first term, this is going to equal, you're going to start at 1, so for k, so 2 times 1. Then you're going to add, then you go to 2. 2 times 2. So this is like the first term, this is the second term, and we're going to keep going till we get to k being 5. So the upper limit. So then the next term is going to be 2 times 3, and then 2 times 4, and then 2 times 5. We're going to stop at 5 because that's our upper limit for k. So you can just write those terms out. Each term is found by going 2 times whatever k is. Okay, so hopefully that all makes sense. And then because it's summation, we're adding these up. So now we just do the math. 2 plus 4 plus 6 plus 8 plus 10. So there's a 10, there's a 10, and there's a 10. Looks like this equals 30. Okay, so you're just adding those up. It's called summation notation, and you use that Greek letter sigma. And it looks like that's all I have for this video. We'll give you another example in the next video.